Good morning. I'd like to thank you all for coming. I'm Louis Gilbert. I'm the managing director. It says here I'm the managing director at the Institute on the Environment, which is a member of the university's Consortium on Law and Values, which is the host of this event. This lecture series is brought to you jointly by the Consortium on Law and Values in Health, Environment, and Life Sciences, the Institute on the Environment, the Center for Infectious Disease Research and Prevention, that's CIDRAP, the Food Protection and Defense Institute, and I would like to thank the Planning Committee, which includes Mike Osterholm, whom you will hear from later, CIDRAP, who is director of CIDRAP, Amy Kirscher from the Food Protection and Defense Institute, and Susan Wolf, who chairs the consortium, and myself. The consortium is a university-wide center that links 20 leading university centers and programs to address cutting-edge societal issues posed by biomedicine and the life sciences. And we'd like to thank the consortium staff and Laura O'Neill from CIDRAP for managing the logistics of the lecture series, and I would extend that thanks wholeheartedly. I have things in my hands that I didn't have a while ago, and I really deeply appreciate that. Our speaker today is Joanna Mazet from the University of California at Davis, and she's going to speak on ending the pandemic era, science at the animal-human environmental interface. Professor Mazet will speak for approximately 40 minutes. Mike will then give some commentary, and then we'll have questions from the audience, and I will moderate. And I'll give you an introduction on Mike in just before he speaks. So, instructions to the audience. So pay attention here. We will open for questions and comments after Dr. Osterholm gives his perspectives. We have 2 microphones near the stage. To ask a question, please form a line behind either mic. We ask that you identify yourself before asking a question so that we can get to know each other and the great expertise in the room. We are really thrilled with the extent of webcast participation today. The event is being videotaped and simulcast. I hear that there are more than 100 people online. We welcome you, folks online, and look forward to your questions as well. I understand we have technology for getting that here. The video will be posted on the consortium website in about 10 days. Please turn off your cell phones and other electronic devices. If you need to leave the room, please use the doors at the back rather than the doors closer to the front. To get continuing medical education, CMA or CME, or continuing legal education, CLE, credit for in-person attendance, you need to complete and submit a participant tracker form at registration. CLE credit is also available for those participating by a webcast, and you can do that by emailing the consortium at consortium@umn.edu, and I'll leave it to your cleverness to find that if you didn't get it on the first pass. We'll have an evaluation. An evaluation form will be emailed to you, and we would greatly appreciate your feedback. Both positive and negative, really helps us design these series, and in particular, it helps us shape the audience, which I have plugged as top drawer. We've identified disclosures. Copy of all disclosure statements are on the registration table for those who wish to review them. The speakers and the planning committee do not have any relevant disclosures. So, let me now introduce Joanna Mazet. It's our pleasure to have Dr. Joanna Mazet here with us. She's a professor of epidemiology and disease ecology and executive director of the One Health Institute in the UC Davis School of Veterinary Medicine. She focuses on global health problems. She focuses on global health problem solving, especially for emerging infectious disease and conservation challenges. Dr. Mazet is active in international One Health research programs, most notably in relation to disease transmission among wildlife, domestic animals, and people, as well as the ecological drivers of disease emergence. Currently, she is the global director of a $175 million viral emergence early warning project named PREDICT. That's part of it. We have a related program here at the U called RESPOND. So I think probably Joanna will predict and we'll try and do something about it or something along those lines. And actually, it's not called RESPOND anymore. It's called One Health Workforce. So PREDICT has been developed with the U.S. Agency for International Development's Emerging Pandemic Threats Program. She was elected to the National Academy of Medicine in 2013 in recognition of her successful and innovative approach to emerging environmental and global health threats. With that, it's my pleasure to invite Joanna to the stage.
Thanks. I'm super happy to be here. I'm trying to fly the colors, so I hope I rock that instead of my rear on the sidewalk because I don't know how to walk in ice. So I hope no one slipped on the way in. Thank you for coming. So I'm super thrilled to be here also because of the partnership that Professor Gilbert mentioned. So we have been at UC Davis in close collaboration with University of Minnesota over, for many, many years. Dr. Osterholm has tons of relationships with our university as well, but specifically for some of the work I'm going to talk about today, University of Minnesota is a leader of what was called the RESPOND project and now the One Health Workforce, and I see some of my colleagues from that program here as well. So hopefully when we get to the discussion, we can talk about some of that some more. So as I mentioned, I'm going to talk to you a little bit about a proof of concept. Can we make a difference? Can we use science to change policy and prevent, if you will? I know our project is called PREDICT, but really what we're about is preparedness and prevention. And can we get ahead of some of these infectious diseases? And flu is going around now, as well as lots of other respiratory things. Many of us are sniffling in the room, right? Hopefully no one has influenza. Please stay home if you do. And maybe the 100 people, hopefully not all on the web. Yeah. But it is a challenge. We are in an era of responsiveness, which we need to be prepared to respond, but wouldn't it be nicer if we didn't have to be constantly chasing the last epidemic? Because what happens is we spend a lot of resources on what has just been, rather than getting ready for what is coming next. And so that's really the goal of a big consortium of people around the world that I'll talk about today and that I have the extreme privilege of being the leader of right now. Maybe not after today. No, so far so good. But that group of people, some of the folks in the leadership decided we should try. We should try to get in front of these things. We should try, respond, if you will, to a call to action. And U.S. Agency for International Development was one funder that I think decided to be more proactive. They decided they wanted to stop paying. Frankly, they still pay for lots of vaccine to get distributed around the developing world. So that's a big part of what they do. They do lots of development work, capacity building work, but a big part of it is assistance for infectious diseases. And when you are the one paying the bill for millions to more of vaccine to be delivered after the epidemic is probably already burning out, you start to think about what can we do differently. And I think the very cool thing about that is that they decided to go ahead and invest in a One Health paradigm. Instead of just keep going simply on the human health side, what has been, what we can sort of anticipate from the influenza world, the best work in this is certainly in the influenza world. They decided let's think about it differently. Let's bring in the ethical side. Let's bring in the environmental side. Let's bring in the animal and economic piece that goes along with that. So I'm thrilled also to be here as part of an invitee from your consortium because I think it's in the same philosophical vein. So here's the issue, and I actually have most of my background, my foundational work and training in wildlife epidemiology, and I am a veterinarian. I didn't continuing veterinary education credit, by the way, sir. How do we get that for these folks? No, I'm just teasing. But we want to think about the veterinary side as well, because we're thinking, where do these viruses come from? Well, if you look at the green area here on the slide, most of the emerging infectious diseases have their host, their reservoir host, in a wildlife species. Now, the wildlife's not a villain. We are interacting with wildlife differently, and we continue to grow our populations and encroach on the areas where the wildlife's living with our domestic animals for our food. And so there is more and more mixing of people and wildlife, and again, our food supply, our domestic animals. And so logically, there's more opportunity for spillover. So spillover from the wildlife to livestock or directly to humans. Sometimes when we go to livestock, we'll have a food safety and food security issue, but we also can see amplification. Likely the situation we're seeing with MERS and camels, right? So we can see amplification, can cook along for a while, maybe change a bit, and then spill over to people and cause disease effects. So really what we want is we want to change the epidemic curve. We want to think about moving back, if you will, to understand better what is out there, understand how interactions are facilitating spillover and disease amplification and spread. So to do that, what do we need to do? We need to have some prediction. We need to have some better models forecasting. We were talking about weather as we started just sitting here visiting. And I think, the Obama administration was starting to really look at, can we have a forecasting service like the National Weather Service for epidemics? And there was a big push for that. And I can tell you, and working with the Weather Service folks, that they will tell you we had at least 50 years of good data in order to start even coming close to being able to tell you if you're going to have icy rain today, right? And what do we have as far as wildlife? The wildlife folks out here will tell you there's just a smattering of people around the world doing a little bit of work here, a little bit of work here in the big picture. They're doing great work, but do we have that database? Do we have that rain gauge and temperature type of data that can be collected and was collected for 50 years before there was a good forecast? We absolutely do not. So any models that we put together now are not as robust as we would want to stake any kind of claim that we have the ability to predict. So we need to collect that data. And then what else do we need to do? Well, we need to be able to detect viruses. Specifically, I'm going to talk mostly about viruses because when we think about epidemic pandemics, we're really talking about viruses, and even more specifically, we worry about RNA-based RNA viruses. So I'm really going to focus on that today. Maybe in the discussion, if you want to talk about bacteria or antimicrobial resistance, other big issues and threats, we can do that. But we want to reduce those epidemic curves. So for the domestic animals, the blue one, we want to get it down. We need to be able to detect. We need to kind of know what's out there and be able to detect at the source. For humans, for sure. When we see things like the West Africa Ebola outbreak, what happened? It happens over and over again. We're not expecting that virus or that pathogen to be there. We don't have the diagnostics in place. We don't have the community programs and education programs and sensitization in place. We don't have the public health infrastructure to deal with it because we don't expect it to come. So when it does come, we look for something else. And we spend months thinking about, well, we have this endemic loss of fever in the case of the West Africa Ebola outbreak. We have a disease we're expecting. It must be that. Even though the diagnostics are not matching up, it still must be that. And we waste weeks to months before we get going. And so that allows the red curve to get too high. And what we really want to do is decrease it. So we can talk about lives lost, right? And that's the real cost and the real concern. But to make an argument for whether or not we should invest, right, your tax dollars, frankly, in looking for and understanding how to forecast and how to prepare for these kinds of emerging pathogens, we need to think about the money too. Right? There has to be an economic argument. And so the World Bank has been doing a lot of work in this area with, again, a lot of great people, great economists around the world. But just if you look at the actual facts, okay, if you take 6 outbreaks that occurred between 1997 and 2009, none of them a big one, none of them like the West Africa Ebola outbreak, but regular zoonotic disease outbreaks. That cost about $80 billion to deal with over that time period, okay? And the forecasting was if you could prevent some of that, you would have saved about $6.7 billion US a year in that same time period. Unfortunately, things have gotten worse. And since then, the new estimates are that we are actually spending $30 billion globally, spending $30 billion a year right now on this pandemic risk. That expected value, it has a lot to do with how we worry about pandemics, not actually responding to pandemics, okay? So that is you guys all buying Tamiflu, right, when you think avian flu is coming around. Us taking airplanes apart when we don't really understand how to clean a plane because someone had Ebola who was on an airplane, okay? That is a huge, huge cost. The actual cost of the outbreaks, so talking about the West African Ebola outbreak, now there were a lot of donors, a lot of participants, but the loss in GDP just to the 3 most affected countries was $2 to $3 billion, and the US has contributed directly just to respond about $4 billion. I can tell you, even though multiple agencies in our government spent that kind of money to get over there and help, right, to actually do the diagnostics and the disease control, we left behind not a single laboratory for the country that can diagnose Ebola. Okay? This is what we can't keep doing. We can't keep doing this over and over and over again. But it is the only mechanism we have right now. So again, the forecasting from World Bank says that if we did have a serious pandemic, a really bad flu with a high mortality rate, we're talking about $3 trillion likely for one response. So that just brings us back to getting ahead of this curve. What is it worth? We have to prioritize prevention. And I just want to talk about our consortium a little bit. As I mentioned, at UC Davis, we're lucky enough to be the hub, if you will. But we have a wonderful consortium, including Wildlife Conservation Society, EcoHealth Alliance, both headquartered out of New York City, Metabiota out on the West Coast with us at Davis, and then Smithsonian Institution in in Washington, D.C. But we're working with the Ministries of Health, Agriculture, and Environment in all of the countries that we work. We've been engaged in 35 countries. Latin America is now phased out, so we're in 30 countries currently. And a huge number of implementing organizations, including universities in all of the countries where we work. So it's an amazing group of people putting their minds and their sweat, frankly, to making this happen. Okay, so how do we do it? Well, again, really what we're engaged in is, frankly, a very expensive proof of concept as to whether or not you can start to collect this data and get ahead of this curve. And so we continue to do the modeling and try to focus our targets on where we should do the work. And really looking at, from the ground and with our teams from the countries, looking at key interfaces and what's happening on the ground. Talk a little bit more about that. And then taxonomically also focusing. We have to improve pathogen diagnostics and the ability to discover so that when a new virus or something else shows up in a country, the country has the ability to do that work internally. And that's a big motivation of the global health security agenda that's being very much supported by countries all over the world. And that includes multiple techniques, but molecular identification of both known and unknown agents. So if you can do both, why not, right? Why not be able to pick up things we know are out there while also being able to detect new things? And then that requires a lot of bioinformatics and reporting structures. And there's a huge ethical component, and I know that that's part of what this whole series is about the legal and ethical side, and I hope we'll discuss that more. We did focus on rodents, bats, and non-human primates. We were kind of flying the plane as we were building it, frankly, when we started this. We then, there was a lot of gut feeling and literature out there that would point us in the direction of these taxonomic groups, but also, of course, birds and pigs when we think about flu, and then carnivores and ungulates, the things we live with and we eat, right? And so we have a lot of connection with. So that's how we started. Our work then kept evolving, and we had epidemiologic modeling and ecological modeling, and thankfully the gut was right, and all of the good hard data that we could collect from every epidemic zoonotic spillover event that we could document since the beginning of time, or scientific writing, pointed us to the highest risk still being in those top 3 bold groups. We also could look at every interface for every spillover event for an emerging infectious disease. So on this graphic, all of the red dots are viruses, zoonotic viruses, where there's a documented spillover. We know how a human was exposed. And if we look at the experience and the interface where that spillover happened, we can start to get the red and green and yellow. So vector-borne disease over here, there's a lot of vector-borne viruses, right? And we know kind of how those work. Now, fewer of those vector-borne viruses can also be transmitted in the green and blue mechanisms with direct transmission or indirect, like aerosolized transmission. So really there was a great group, primarily from the US government side, coming out of the CDC realm, that were working on vector-borne. So our PREDICT team really focused on the messier side of this graphic, where we had the indirect and direct transmission through things like human-dwelling interactions, like rodents in your house, right? Bats in your belfry, if you will. That's what they say to me all the time anyway. But laboratorians, you know, we infect ourselves quite well, it turns out, if you look at the literature. But things like bushmeat hunting down here in the blue. And the viruses get fatter in this graphic, the more different interfaces they have been transmitted in. And that makes you worry. So if a virus is able to have a lot of different ways to get into a person, we start to worry more about that virus. What else do we worry about? We worry about viruses, and actually this same paper, if you take a peek at it, we worry about viruses that have high host plasticity, and by that I mean host breadth. They can infect lots of different hosts. The more likely, the viruses with more host breadth or plasticity, the more likely we are to see a spillover, and the more likely we are to see that virus be able to go to human transmission, which is the real danger, right, for pandemics. So just quickly, a couple of interfaces to talk about here. This is the kind of work you can't get from the literature. You can't, when we started, you can now because we published a bunch of papers on it, but as have others. But when you get going and you start to say, where am I going to target? You can't say this country, Thailand, is an important country, but you can't just go all over Thailand, right? You can't have thousands of people in every country running around sampling animals to find virus, right? You have to target. And so we start to work with the teams to evaluate what kind of interfaces, what kind of intimate interactions are occurring in these countries where we're working. And it turns out bat guano farming in Southeast Asia is becoming a very much more and more popular, lucrative kind of profession. Well, what happens in bat guano farming? You build a condo for the bats, as you see here. You build these kinds of nice condos with palm fronds, and the bats will leave the forest, and they'll come hang out here. High rent district, right? So if you build it, they will come and they will poop for you, okay? Saying poop on the TV, you know, but these folks obviously are not well protected. They're not wearing any PPE, and what are they going to do with that guano? They are going to put it directly onto their farm, and they're going to sell it to other farmers to put on their farm. Okay, what do we know about bat guano? Well, not a lot, but we can test it and find out there are some pretty bad viruses in there, okay? Things like MERS and SARS and very closely related viruses that scare us, right? And that have cost us, again, billions of dollars to respond. So both we need these people to be safe, and we need them to be practicing good practices. So here they're putting this out in the UV before they put it on their farms. Maybe that works. We don't want to come in and say, you can't do anything, right? That's the worst. Scientists are the worst. We come in and we say, that's dangerous, that's dangerous, that's dangerous. Sorry, your family's hungry, don't eat. You know, we don't give people the economic options right? To say, that's a risky behavior, this is a less risky behavior, this is a zero risk behavior if you can go do this, right? So we need to be thinking about the ethics of what we're doing, not just recommending what not to do, but recommending what to do better, okay? And so maybe this takes care of it. And if these guys were wearing personal protective equipment, they would be safe enough, and they could have this lucrative profession. But maybe this isn't safe enough. We should know, right? We should know. And maybe we should recommend that this isn't the right thing, that we find alternative ways for fertilizer or other options for them. This is Kathmandu. This is where my food comes from when I go there, okay? And I go there a couple times a year, right? And so this is the situation. Whether or not it looks like a beautiful tourist hotel, people are going to climb Everest, this is the situation of the food safety in the country. And so we need to just be thinking about that. This is, mixing of wildlife, domestic, livestock, pseudo-domestic livestock, all combined. And actually, this is a funeral pyre here, and so this is a huge tourist destination temple. But people are also burning and burying their dead, and I can tell you that their remains go right into the river that flows right through the city, and they're not so burned always, okay? And so there's just ample opportunity for this kind of transmission. So what do? We work on looking for those high-risk interfaces without sort of putting to the side. It would be easier not to think about those ecological drivers, the large-scale ecological drivers, but we have to. We have to think about economics. We have to think about land use change, human population density, climate variability. So we put those more and more into the models, and our teams now are collecting that data. While they're swabbing people and asking them about their risk, they're also collecting the environmental data in those same situations. So we do the modeling, we get out, we do the field studies, get that into the laboratory. You got to build capacity in the laboratory to make that happen. And then you get that data back into the probabilistic models to make it better. And so that's the basis. It's a never-ending cycle. You're trying to make the models better and better so that you target better and better and look for what you can find. But the laboratory piece is very difficult. It's very expensive. And it's hard to make sustainable, right? Because just like I said with Ebola, once the work is gone, why is the laboratory there? The people get hired to go into other fields or out of the country. So that piece is proving to be an ongoing challenge, I think, for all global health efforts. So what were we able to do? So I'm going to talk about just the first 5 years really briefly, because I'm going to talk a little bit more about this later. But in 5 years, we were able to train people in the countries where we were working. They collected samples from 56,000 animals, primarily wildlife, in the first 5 years, okay? And you can see he's being safe. He's got a monkey there. We don't kill the monkeys, right? We're also safe for them. So there's all sorts of training involved. Also learning involved. Some of the teams from the countries where we work knew very much better than our global team how to catch that monkey, right? So it is collaborative, and we all are learning. And we send people from one country where they're good at catching monkeys to neighboring countries where they're not, right? And so we have this back and forth across countries, which has made a really rich group. And we had to come up with other methods. So in some places, the monkeys are endangered or protected, or they're revered in religious circumstances. And so you can't catch them up, right? You can't, even if you're going to be completely ethical according to IACOC and you're not going to hurt them, you still can't catch them up. People will just not allow it. So we had to come up with other non-invasive methods. This is a monkey chewing on some strawberry jam, and they get sick of it, they get bored, they let it go, and we can get virus. And we're able to work with our primate centers and our zoos actually to test that with an anesthesia and swabbing and compare it to banana versus strawberry versus nylon rope versus cotton rope so that we can get the good science done to know that we're getting the most virus that is most reflective of what's in that little guy's mouth. And then building the capacity we had to come up with a whole different diagnostic platform. And so we went to consensus PCR actually looking for conserved regions of viral families as opposed to a couple of different ways we could have gone. We could have gone to a metagenomic platform, but really expensive, and frankly, we'd have to export all the samples out of the countries, and the wildlife and the samples belong to the countries. So that wasn't very practical or fair, because you don't build capacity that way. With the consensus PCR, you can target all the viral families that I showed you before in the network analysis that have caused epidemics in the past. And so we could do really sort of basic, easy PCR, right? Conventional PCR to find the viruses. Then when you get positives, you have to sequence them to know which virus it is, right? So you have to get it sequenced. And we had to build laboratory capacity. So this is my very clever colleagues at Sokoine University of Agriculture. The only lab they had was a lab where they taught all of their students how to do laboratory techniques. And we thought we shouldn't probably try to find the world's most deadly viruses in the students' lab. So they said, well, okay, we'll figure something out. And they did. They stacked a couple storage containers and made a beautiful laboratory for 40 grand. A lab that would cost here, I know because it would cost in my place as well, many, many millions to build the same thing. But it has its own internet, its own generator, its own air conditioning. It's where everyone wants to hang out because it's cool, which is not good for world's deadliest viruses. No, but it has great flow. It's small, but it has great flow. We can do compartmentalize all the different parts of the work. So in the first 5 years, we trained 32 laboratories, and by the end of 5 years, we had 27 of those 32 laboratories being able to screen for those target viral families. So that was a huge, huge piece for us that really showed us that we were being successful, because they can still do that in those countries, whether or not politically our money goes away tomorrow, right? Which it could, unfortunately. But let's not dwell. In the first 5 years, we ran over 400,000 diagnostic tests, and we did see that bats, non-human primates, were coming through as having the most virus we could pull out, okay? So we did, still the rodents are up there, but the bats and non-human primates really pointing in the direction of worry. We found over 1,000 viruses in the first 5 years. 80% of those were novel, okay? Novel, but again, only in a viral family that can infect, that has been shown to infect and cause epidemics in people, and only in a sample that is transmittable. So again, we're only looking at that interface. So if we're at the bat guano farm, we're looking in guano. Okay, we're looking at the sample that is likely to be have exposure to humans. So these were in, some of the bad actors, right? So the certainly flavies, hantas, influenzas, coronas, rhabdos, they're ones I guess is what I should say. Because we're academics and we're an academic institution. Now at a little more than 7 years, we're up to more than 120 publications coming out in 7 years from the consortium. So we're really, really proud of the teams and what they've been able to find. And some of it is following up on big things like SARS and finding new ways of transmission and new sources for these viruses. Others, like in Thailand, bat guano farming, again, finding that MERS-like coronaviruses, okay, and starting to understand, again, the host plasticity and the viral diversity. So just a peek into what we might be able to find if we were doing this even on a larger scale. And then we're responsive and getting out there and working with the teams to be able to respond to needs. So people suddenly really worried about camels, so we got to train on camels. We got to be ready. We got to be prepared. We got to deploy folks. I think this is Indonesia. So you never know. Now I know where there are camels, and they are everywhere, I can tell you. So just being responsive to the current world needs. Also, for my conservation-oriented folks in the crowd, we're finding human viruses in the wildlife as well. So it's not unidirectional, right? It's not just worrying about viruses that are going to spill over from hosts, but we're finding in endangered mountain gorillas, we're finding human viruses circulating that year in the human population, killing endangered species. Okay, so this has huge implications for the conservation community and how we manage and handle our work with mountain gorillas and other species. So it has this, what some call a halo effect. It's not the reason that we're asked to do the work, but it is the outcome and some of the motivation for the scientists that are working in the field. All right, and that, as I mentioned, this allows us to get better and better at predicting our models and understanding more and more the drivers like mammalian diversity changing in agricultural systems, changing in population density. We also responded to outbreaks. In the first 5 years, we did 23 outbreaks. I can tell you the bags under my eyes are real right now. We're helping about 6 countries either respond or prepare to respond to outbreaks right now. So the pager is constantly going off. It used to be a pager. I used to do oil spills. It's my phone now. I don't also carry a pager, but it feels like a pager. They bother me all night. No, it's good work, but it keeps you super busy. But we were able to work with countries to start to get the animal side into their outbreak investigations, and that's new. Environmental pieces and environmental information into their outbreak investigations. So we're really, really proud that the One Health paradigm is starting to expand into the practical side of emergency response as well. All right, and then we got to get the data out. So the data has to be, as I mentioned, the samples of the animals are owned by governments, and they own the data, so they have to be the ones to agree to release it publicly. So we have a whole system by which we share it with all the ministries involved. They agree to public release, and then we get it out to the world through a health map interface, as well as GenBank when the full sequence is released. The next stage that's really difficult and that we're working on now is how to rank all the viruses you find for risk. Which ones are going to be the ones that spill over? Which ones are going to be the ones that could cause an epidemic? And we're working hard again with that One Health paradigm to bring in the ecologic and the environmental side, the epidemiologic side, not just the virologic side, which is how the work has been done in the past. So hopefully you'll see something from us really soon on that, because it's irresponsible of us to go and find all these viruses and not be able to say anything about them, right? Okay, I'm going to power through because we don't have a ton of time, and I believe I've sort of covered this for you already. I want to get to the next phase and what's happening now. And so really now what's changed between the first 5 years and this current phase, the second 5 years, is that we're looking at livestock and people as well, and looking at the risks and the interfaces across the wildlife, livestock, human barriers or lack of barriers, and looking for viral sharing. So not only do we know that the people might be exposed to this virus that might be pathogenic, but have the people been exposed? Are we occupationally, are we looking at their threats? In the clinics where people have unknown fevers, do they have viruses that we're finding out in the environment? And so that's sort of the story that's yet to be told. I hope to be able to come to you in a couple of years with all of our findings there. But even before that happened, policymakers very flatteringly took some of our work and said, let's go now. Let's go to the next level. Let's find the viruses. Why do we know about all the bacteria and we don't know about all the viruses? And I think that's a really good question. So is it time now to move to a new paradigm? We've talked about this. It's looking like the best models are showing us that there are about 3 new emerging viral diseases every single year. Can we handle that without being ready? Probably not. So we should get ahead of that curve. We know we're not prepared. Every single time there is a new disease, we start chasing it, right? And then what are we doing? Right now, we're focused on Zika. What's going to be next? It probably won't be Zika. It'll be something we're not ready for because we're spending our time on Zika. Zika needs to be handled, don't get me wrong, but wouldn't it be nice to have been ready for it, right? We could have predicted it. And so there's a global move for a global virome project. And so I was in Beijing yesterday working with an international consortium, including World Health Organization, Food and Agriculture Organization, Merck, and Institut Pasteur, and all sorts of really cool viral institutes and ecological institutes around the world that want to actually take this thing, not viral, we'll go global, okay? And so the Global Virome Project, the idea is it is actually possible to get people in every country of the world out and look at all of the viruses. You can find them, okay? Is it practically feasible? Is it cost effective? Could you do it? Well, we said one epidemic could cost $3 trillion, right? So is it cost effective? Well, if you really all at once started in every country or scaled it over 10 years, tried to get every country all of the viruses that you could get in every country over a 10-year period, it would cost about $3.5 billion. So it's not cheap. It's not cheap, but it's cheaper if that led you to prevent, or if that led you to prepare, or if that led you to develop countermeasures like better antivirals or better vaccines, it would be cheaper. That if part is a big question, right? Can you get there? Can you use the data? Well, the underpinnings are that we know now that there are probably about 1.1 million viruses out there that have zoonotic potential. And about 500,000 of those could jump, okay? So not all of them that have potential can infect humans, but a little less than half of those, based on the information we have now from the PREDICT project and elsewhere, tells us that's a possibility. This is, again, now these are the numbers up to 7 years. We've trained about 3,300 people, so we know we can train and people can get out and do this work. We also know there are other consortiums that aren't involved that could easily come up to speed and participate. We're now working in 60 labs, so we're getting closer, right? There's only a little over 190 countries. We've got 60 labs going. We could get more, but it does have that big price tag. But we also, our science is showing us that we basically know about how we'll be able to detect saturation. So as we work with different hosts in different areas, we can look at all the mammalian diversity and all the water birds, and we can saturate the curves. We know now how to estimate and get good sample sizes, and I can tell you in the PREDICT project, we don't have adequate sample sizes to saturate. That's why we know it's going to cost on the order of billions instead of hundreds of millions to do this work. But the world will have to decide if it's worth it. What could be the outcome? Well, if we had all the environmental data, ecological data, and all of the viral data out there that's available for us to know right now, what could we do with it? Well, we could address that host plasticity issue. We would understand where viruses are, that they are in hosts that are in West Africa before it spills over, so that people could be ready for Ebola, have diagnostic platforms to detect it when it comes, right? We would be able to rank the risk because we would understand the host and geographical and ecological circumstances where all of these viruses are existing. So we would have the information on which to base the risk models, the weather service, if you will, that we don't have now. We would also be able to take and get these viruses in the hands of the virologists so that they could do better, right? So that they could actually make vaccines and antivirals, not just to the last one thing that came, but the holy grail, maybe to a whole viral family, like a broad influenza vaccine, so that we all aren't every 2 or 3 years getting the wrong flu shot, right? That is the goal. And we're seeing the influenza people are trying this now, and I get calls from them and say, do you have some more animal, like dog influenzas? Because we've just been using the human, I think we need some more other kind of influenzas, right? So people are recognizing that this data and these viruses are missing from our research portfolio. And that if we had them, we would be able to do so much more. We could also ping when somebody, all of you probably, there are people here who have identified a new virus in your work, right? You could then ping a database and say, has it been found before? Where? In what species? In what ecological circumstances? Is this one that should be elevated on the risk? So, for example, with Zika, we knew it in Africa where there's innate immunity and years, centuries of evolution, that it wasn't causing much disease, so we didn't worry about it. That's wrong, right? Because we move around the earth now. How many hosts could it infect? Well, we knew it was in birds, and we knew it was in monkeys, and we knew it was in people. It should have been much higher on our list, but that's not the way we do it. We still do it with, well, over there it's not causing much disease, but we forget to watch as it moves around into non-immune populations and how it changes over time. Okay. Also, it'll probably get cheaper. So the next time I talk to you, I don't know whether or not this project will be any further along globally than it is now, but I can tell you the price tag will go down because every single day, the cost of sequencing and technology is going down dramatically. And frankly, why is that happening? It's happening a great deal because of another crazy project that people like me went around and talked about and tried to get momentum building that everybody thought was something that couldn't be done and shouldn't be done, the Human Genome Project, okay? And so the Human Genome Project, for every dollar invested, there was a wealth of information. There's a number, I think it's $183 of return or something. But it's going up and up. I hate to use the actual numbers because it's changing every single day. What used to take months to sequence, we can do in a minute now, okay? And you can do it cheaply, and you can do it in range countries. So we're going to see that impact and data generation is going to get cheaper. So is the time now, or should we wait for it to get a little cheaper? I don't know. I don't know what we can afford in human lives, in animal lives, and in actual dollars. So we really, I guess I feel, even though we're sort of playing with economics and thinking about the long-term cost savings, I can't tell you how strongly, now that I've worked in this field for some time, how strongly I feel about the capacity building and what you do today. Because even if you're waiting and you're trying to do preparedness and preparation for response, if you build the laboratory capacity and the field surveillance capacity, if people have the power in their own countries to be talking to their communities about what they're doing and why they're doing it and trying to get the communities engaged and participating, I think we have the ability to use a project like this not only to create that big data, big science, but to make change now for these places and these countries. So that's what we're after. We can also probably do it cheaper or get started in a different way rather than just going global, right, all at once, trying to do 190-something countries. We could start to target, just as we did in the PREDICT project. And so if we start to look at mammalian diversity and field sites and figure out, what deep in the Amazon is really expensive to get to, but close to a city where there's a high risk and lots of wildlife, but it's not hard to get there, that would be the place to start, right? So we can sort of maximize our initial targets by looking at some of this modeling. So we've done that. There's some countries that are really excited and interested to get started. You can see the country to discover all the virus, basically, in the countries is still expensive on a country-to-country basis. But if you choose carefully, you might start to saturate the curves just by picking some of those targeted high-yield countries. So we estimate for less than 500 million over a 5-year period, you could get really much further along that curve towards saturation, and then make a better plan as to whether or not you need to keep going everywhere. So I think we can move to discussion, and you guys can tell me I'm crazy.
All right, thank you very much. So at this point, I'm going to introduce Michael Osterholm. Michael is Regents Professor and McKnight Endowed. Yeah, right. There we go. Presidential Chair in Public Health here at the University of Minnesota. He, too, is a global traveler. He is an internationally recognized expert in infectious disease epidemiology. Dr. Osterholm has led investigations into infectious disease outbreaks during his 15 years as state epidemiologist in the Minnesota Department of Health. Here at the U, he is the director of CIDRAP. He has received numerous honors, including the Charles C. Shepard Science Award from the CDC, the Harvey W. Wiley Medal from the FDA, the Squibb Award from the Infectious Diseases Society of America, and the Wade Hampton Frost Leadership Award from the American Public Health Association. He's a frequent consultant to the World Health Organization, the NIH, the FDA, the Department of Defense, and the CDC. He's a member of the National Academy of Medicine and a fellow of the American College of Epidemiology, as well as IDSA, which is the Infectious Disease Society of America. Michael.
Thank you. Thank you, Louis. And as you can probably tell, I'm actually suffering from an infectious agent here today. I do not believe I'm infectious unless I kiss you, so don't anybody agree to that. And I did pick it up while I was in Washington all of last week, so God knows what I have. If anybody read the Oregonian paper yesterday, you saw that one of the front page major stories was an interview with Bill Gates, who indicated in his biggest concern for all of the future of the world is the next pandemic, which is coming. He didn't say if, it is coming, and what it might be, and he, of course, is concerned about influenza. Well, today, in terms of my commentary to respond to your very nice presentation, and thank you for being here to do that, let me just, as background, just give you a sense of where the glasses I see the world from. I have spent 42 years in public health, many of them at the interface of outbreak investigation and disease prevention, as well as the very heart of surveillance. I've been very involved with, over the past 18 months, with an international effort called the Coalition for Epidemic Preparedness and Innovations, which is a collaborative effort of the Wellcome Trust, the Gates Foundation, the countries of Norway and India, as well as the World Economic Forum, to actually figure out how to deal with getting our needed vaccines that we need that today have no market for them. I have a book coming out on March 14th, Deadliest Enemies, Our War Against Killer Germs. I only tell you that not to promote the book, but the fact I spent hundreds and hundreds and hundreds of hours interviewing some of the brightest minds in the world in the 2 years leading up to finishing that book, including people like Mr. Gates, trying to really bring together a synthesis of what do we know, what can we do, and how do we do it. And at CIDRAP, over the past several years, we've been very involved. I co-chair a group called Ebola Vaccine Team B with Jeremy Farah from the Wellcome Trust, in which we've looked at the progress or lack thereof of trying to develop an Ebola-prepared world using Ebola vaccines, and it really serves as a primer for where we're at in many other areas. Let me just say at the outset, readiness and preparedness in themselves are more than just words. It means you actually can do something about it. And I think the unfortunate reality is today, I don't see much of the work that we've just heard about really getting us better prepared for the future. And I will share with you why I think that to be the case. I love surveillance, I love data, but in the end, imagine you have a 1,000-mile railroad track, which is the beginning to the end of any countermeasure, a vaccine, a drug, or some kind of other intervention. And that first 998 miles aren't bad, pretty much flat terrain, some ups and downs, but that last 2 miles has to cross the Grand Canyon. And today, that's where our countermeasures are. Why do we not have an Ebola-prepared world yet? Our Ebola vaccines, which should have been a very high priority before West Africa, in fact, are still not near achievement of licensed and available vaccines. Our Team B report of just several weeks ago highlights the problem with that. We have 2 vaccines that are in phase 3 trials. We have 2 vaccines that are in phase 2 trials. One of those companies just pulled out after spending $400 million and losing their shirts on it. Today, the only pot at the end of the rainbow is a $5 million pot to buy vaccine for Gavi, which if you're investing $400 to $500 million, why would you find that so rewarding to get $5 million back? We don't have a system today for countermeasures. As part of CIPI, the group I just mentioned, we prioritize 12 different vaccines that we need to bring forward over the course of the upcoming years. Just 12 out of all the diseases, because those are vaccines for which we need, like MERS. MERS, we talked about coronaviruses, only in phase 1. We have 1 vaccine in phase 1. Well, why is this the case? Because it is very expensive, and there is not a global system for bringing these countermeasures forward. We estimate today, for example, for a new flu vaccine, which we desperately need, the current flu vaccines are grossly inadequate to handle both in terms of protection and also the number of the doses we would have at any time for a pandemic. Yet last year we spent about $35 million in the world on new game-changing flu vaccines. That's it. So the point being is that we really haven't awoken to the need for these unless there's a market pull, meaning you can sell HPV vaccines, you can sell shingles vaccines if there's a market pull. But if there is not, there is no market. And there is no job. The SARS vaccines were a classic example in 2003 and 4. At that time, and I was at HHS splitting my time between here and there and was very involved with getting companies excited about getting into SARS. They did. They invested many hundreds of millions of dollars. And then SARS went away and we said, oh, never mind. They lost their shirts. The pharmaceutical industry had that happen to them again with Ebola. And they're done. They're not going to get involved anymore. So the point being, unless we create a very unique pull to get these countermeasures through, we can find all the viruses in the world and it won't make a damn bit of difference. That's where we're at today. When we look at influenza vaccine as a good example, today we are seeing unprecedented activity in the avian interface with H5 and a number of N different types, H7N9. The H5N1 vaccines we have today were made 12 years ago, which we know the virus has changed a great deal since that time. The United States is the only one that has a stockpile, and we don't even know what the potency really is of that vaccine. And it would literally be a drop of water in Lake Superior if we needed to use it for the world with an H5N1 emergence. H7N9, right now we're seeing a major activity in China with that virus. We already know it's there. We know it's a potential challenge. It's one that doesn't get birds sick, but it gets people very sick and 30% die. That's a vaccine that we made 3 years ago, and already we're seeing major changes in this H7N9 versus the one in the vaccine. And we have no evidence that it would be cross-protective. And we're not even investing in that. And the United States, by the way, is the only country investing. World Health Organization stopped any kind of activity around stockpiling flu vaccines in 2013. Take Ebola. I mentioned it just a moment ago. The companies right now are literally on the edge of pulling out of this, because they see no big plan. We have a meeting in Paris in 2 weeks to deal with this very issue, to try to take what limited resources in CIPI, which is only $400 million right now, and all the other vaccines, to try to keep them in the game. So it's not enough to identify something. We have major threats we know right now that we should, could, and must respond to, and we're not. We have a very ill-prepared world because we haven't figured out how to pull them across that last 2 miles of the Grand Canyon. I just give you one example of one that also for anticipating. 38 months ago this month, I gave my first lecture on Zika. And I said, it's coming, it's going to be hell, and at that time we didn't fully understand the whole issue of microcephaly. And despite those warnings, nobody took any interest in Zika till it was here. We have a number of different issues where we can forecast right now. MERS is another example. I'm absolutely convinced from our own work, and I have been in the Middle East working on MERS. I was in Seoul, Korea working on MERS in the outbreak at Samsung Medical Center. What we have right now is a very unique environment where on the Arabian Peninsula there are about 1.5 million dromedary camels. That coronavirus MERS is a very different virus than we see in Africa or we see in Asia. Kissing cousins, but different. The challenge is that there are about 7 million camels in the Horn of Africa, including Somalia, which has the highest number of camels in the world. It is just a matter of time before that virus blows out of the Arabian Peninsula, just like Zika did when it blew out of the Pacific, a different virus than the old world Zika virus, and it's going to cross back into the Horn of Africa. Right now, about 99% of all camel trade is from the Horn of Africa to the Arabian Peninsula. It's going to blow back. And when that happens, it's going to do in Eastern Africa what Ebola did in West Africa. And you know what? We're not prepared. We have one MERS vaccine in phase 1 trials right now, and we can't get anybody interested in the large corporate world to deal with that. Do you know that it takes $500 million just to build one vaccine manufacturing plant today that will pass FDA inspection? That has to be dedicated to that antigen only? No company's going to invest in it. So all this push work at the bottom is interesting. kind of exciting, but it's useless if we can't get that last 2 miles of track done. And that's where we sit today. Let me just conclude by saying my worst fear today, besides pandemic influenza, which is really one that I think, and MERS, tomorrow Kinshasa could easily be a gas tanker going up into Ebola, an Ebola match. As much as West Africa was a challenge, there are more people living in the slums of Kinshasa today than lived in all 3 of the slums of the capital cities of West Africa. We know that. And yet, we have a completely stalled out Ebola vaccine program. So, what we need to do today as a world is take a step back and figure out how do we get these really critical countermeasures, and one day wouldn't it be great if we could touch any of these other ones when we have all these other agents out there. So I would like to see a lot less emphasis on all these new agents out there unless we have some risk assessment that they're there. I'd like to complete all 12 of the CIPI vaccines and make sure that now we don't just have vaccine, but that it's actually ready to go, if not already pre-deployed. Imagine we could take Ebola off the map today if we could vaccinate healthcare workers, emergency responders, burial team members, etc., in the affected countries of Africa. Imagine, we wouldn't even have to deal with it again. And yet, we don't have that much creative imagination and financing to make that happen. So, Dr. Mazet, I appreciate your work. I think it's interesting, and as an epidemiologist, I always like data. But in the end, as an old man, all I care about, does a damn thing work? And do we have something that will actually stop the next outbreak or the next pandemic? And right now, a world of countermeasures says we don't. Thank you.
We're going to go to questions. We'll sit here, and I'm going to invite Dr. Mazet to speak back to some of Mike's points. Questions at the microphones. We'll get to those after Dr. Mazet has a few words. Reminder to please say who you are. I think who you are and where you're from, or some kind of identifying information. But Dr. Mazet, please.
Okay. Thanks. Actually, you'll probably be surprised, but I agree with you. Okay. I agree with you to a certain extent. I agree with you that we can't get there with vaccines. I'm actually a big fan of CEPI, so I think CEPI is needed because we're in this situation that we're in right now, and we don't have the data to do anything differently. I agree that we need philanthropic support because it's not a good business choice to get these vaccines made. And where I disagree is that vaccines are the answer to preparedness. I actually don't think vaccines are the answer for readiness and preparedness because of the situation we're in where there is no business model to make it work. Now, if we had a different situation where we could make vaccines and get them to market for under $1 billion, and actually do it more effectively, I may change my view on vaccines being the appropriate best countermeasure. But I'm afraid right now that I completely agree with you that we can't get across that canyon. We can't get there. And without being able to get there, what can we do? And I'll just use the example. Many of you probably never heard that during the West Africa Ebola outbreak, there was an Ebola outbreak in DRC. Okay? Now, I'd just like to compare and contrast those two outbreaks. We weren't working in West Africa at the time. We weren't involved with that outbreak, but we were working in DRC, our teams. But DRC also has known for decades that it has Ebola. So what has it done? Because they know that they have it, they have put systems into place. They've communicated with their citizens. Their citizens are willing to report, and they have diagnostic capacities. That's what I'm talking about is possible with a project like the one that I provocatively laid out for you. Now, unfortunately, during the West Africa outbreak, the laboratorians and the head of the public health lab from DRC were in Liberia, helping out. And luckily, our team was still there. We're embedded in the institute, it's INRB, the National Institute, and we have a viral hemorrhagic diagnostic lab. So we were able to support the government to identify Ebola in samples that were taken just 3 days, basically, from the outbreak beginning. The citizens reported because they've seen Ebola before or they've heard of it, they know. So they reported. The government got out quickly. The government got the samples back, and within 3 days of getting the samples from the field, which was a very short period, we were able to say it is Ebola, but it's not the West African strain. Everybody was afraid that it had been exported from West Africa. So we were able to say, okay, so it's not the West African strain. It's a strain we would expect to see here. And what did they do? Again, within just a few days, they quarantined, and the citizens were okay with that, okay? So they quarantined, they put into different burial practices. All those people that could have blown up very close to Kinshasa, actually, as we discussed, jumped into action because they could diagnose. They had the lab capacity, they had the knowledge of what viruses that they expected to be there, and on the order of 100 people died, rather than the order of magnitude that you saw in West Africa. So that's what you can do if you know what viruses are out there and you prepare for them. No vaccine, okay? I would love to see a vaccine. I think that when we don't know where things are, we really need vaccines. And that's the situation we're in right now. But my argument is perhaps we can't ever get there. And so do we keep doing this, you know, the sort of definition of insanity of doing the same thing over and over again and expecting a different answer? That's my concern.
Thank you. Well, let me just offer an alternative view of what happened in DRC versus West Africa to give you a sense of why the vaccine is so critical. Actually, our group did a major review on Ebola outbreaks, and up to the West African outbreak, there had been 24 outbreaks of Ebola in the previous 60-some years, over about 2,200 cases. And each of those were controlled without a vaccine. But the difference was they were largely in rural Africa, in very small town settings or localized settings, where it was very easy, in a sense, to bring the people together. Africa's changing. The fastest growing area of the world right now are the megacities of Africa, not Asia, Africa. And you have all these cities with more than 10 million people, with even many, many more, over 2 million people. And I just mentioned Kinshasa, 14 million people, of which 6 million people live in the most dire slums you ever saw. And that belt runs all the way from Nairobi, where we have Kibera, all the way to West Africa. That virus in that world is a very different virus than it is in rural Africa. So today we could have a number of outbreaks in rural Africa and bring them under control relatively quickly using the same techniques we'd used for the previous 60 years. A virus like this in Kinshasa, Accra, Nairobi, Kibera is a very different kettle of fish. Vaccine is really very, very key to bringing that under control. And so we could get close to Ebola vaccine and a vaccine-prepared world. But as our Team B report basically illustrated nicely, is once the world forgot, they forgot. And we don't have a system for bringing these countermeasures through, and we don't see them in the public good, meaning we want the pharmaceutical companies to do it, take care of this by assuming all the risk, but not having something they can sell at the other end. The same thing is true with flu. You can't get yourself out of a flu pandemic with behavior. We can't get yourself out of an AIDS pandemic with behavior. And so countermeasures become incredibly important. And we have to understand we are not in a world today of just R&D. That seems to be the focus. That's where it's sexy. In academic centers, that's where we care about it. But in the end, none of that matters if you don't have that last 2 miles of track, which is how do you get these very expensive countermeasures actually into existence when companies are saying, not me, I'm not going to lose another $400, $500, $600 million.
Okay, so let's take some questions. I know we have one here. Could you remind her to say your name and then tell us what you're thinking?
From the Department of Medicine and the Medical School, Infectious Disease person. Terrific talks, both. And the question is to Professor Mazet. You mentioned working with other groups busy predicting, for example, the Weather Service. They're getting better, but they still aren't very good, in
Yeah.
fact. You can predict our winter's going to suck every year for quite a while, but any more granularity isn't a whole lot better than it used to be. I'm interested in other groups that are predicting, for example, Google and Amazon,
Yeah.
and most importantly, pollsters. Almost nobody predicted, as I understood it, that we'd have the president we have right now
One.
in that office, right? But you must be worried about predicting this anti-science impact on all of these issues.
I definitely am, and thank you for the question. I don't. I think I said a lot of nice things about our main funder, USAID. This one is less flattering. I don't like the name PREDICT. I don't think that's what we're really doing. I think we're getting more and more information to better preparedness. While prediction is a wonderful goal, I don't think it's in the short term at all practical, and that's why I use the weather service analogy. It's still kind of sucky, as you said, and it took 50 or more years to get there, right? And so do we have that time? I think what we really can do better is getting all of the pieces into place so that countries can take care of themselves. They won't have the vaccine. I agree with you. They won't have the vaccine, but if they can detect, right, and identify and understand what's going on right at the source, we are in a much better situation. The truth is that in West Africa, this also started in a rural area, and it got to cities. We need to keep things where they started. When they do start, I'm completely with Professor Osterholm. When they start and they start in a city, we're all in big trouble. And we do need the countermeasures. When things start like a house of fire in a big urban area, we're in big trouble. But we're in less trouble if we can identify it that day and not 6 months later when we've let it go all over the world. And that's what we have, the situation we're in right now. We are working with the folks that machine learn and scrub the web, and that's looking very promising. There are things like Flu Near You that you've probably seen, where just based on people Googling symptoms, you start to see where things are starting. And we actually have teams in all the countries where we work that go through the local media and local blogs in local languages that those systems can't capture, because they mostly capture English, Spanish, right, French. There's only a few languages that they capture. So we have our teams as a pilot looking at their local language media sources and online sources to see how much more you capture in a shorter amount of time. It's all about reducing the amount of time. For me, right now, in something that we could do today, because I'm not going to fix the business financing problem. I hope that you can, and Seppi and others can, and that's why I'm a big fan. But right now, what I think our teams, how we can contribute, is shortening that time to identification so that the non-biological countermeasures can go into place. That's not going to help us with airborne pathogens, and I totally agree. With influenza, we're going to have problems. All of you get it. We all try not to, right? So the behavior piece isn't going to help us with that one. So there are certain things that go higher on the risk list for needing vaccines, for sure, when we know we can't control them with behavior.
Hi, thanks. My name is Dominic Travis. I'm in the Veterinary College, but also have appointments in the Institute of Environment and Public Health. And I'd like to think about these things holistically. I came here to work on Respond. And I'm curious from both your perspectives on cost benefit. So you've hit that in a number of ways. Now, as a wildlife person, I have a bias. We look at generally CDC and public health as liberals look at defense spending in that sense. And we try and do things for 10,000 because that's the budget we have. So, Dr. Mazet, you now have more than 10,000. So I'm interested in your perspective in the sense of, to me, this is creating the global wildlife denominator for all of the risk questions and all of the epidemiology questions that intersect with wildlife. That's an overgeneralization, I realize. But how does the opportunity that you have now for the wildlife perspective as it approaches public health and global health how do you think that investment is paying off, and how can we do better? And then Dr. Osterholm, I'm wondering what you see as, in terms of the finances, maybe not the reality of getting them into which is what you were just talking about, but where do you think the next investment needs to be made that's a realistic investment in filling a gap or a hole in that overall system? Thanks.
Yeah, Dom, I'm not sure that I can speak as informedly as I'd like on the actual economics of the day-to-day piece of investing on the wildlife side. I will tell you that wildlife people are scrappy. We tend to use that term all the time, scrappy. You don't have a lab where you can look at these, let's throw together a couple of storage containers and then fix the ventilation. We're doing things an order of a magnitude cheaper than I think anyone thought they could be done, because we're using the people who have never been funded with big dollars. So they're used to doing everything on a shoestring. You give them a little bit of money, they really make a huge benefit, right? So we didn't think we could actually take countries that didn't have a sequencer, and some countries didn't have a PCR machine, and get them to a place where they are actually detecting new virus in their country. And training the people to go out to the field safely, safer than we do it here, frankly. How many of you have had physicians or veterinarians stick their fingers into some orifice, ear or mouth, without gloves on, right? We don't do that in these countries. We're very careful. And how much do we spread diseases around just by our own systems, frankly? So I think I can't speak to the numbers specifically because we haven't run them. But I can tell you that it's much more efficient just because the world is telling us, oh my God, how did you get that done?
Let me set you up this way and re-ask it. You know how much PREDICT has cost?
Yeah.
And I don't know if that's publicly available. I'm
yeah,
assuming it
that's
is.
fine.
How does that compare to the amount of investment in one failed vaccine that was the example of a vaccine that came down that was dropped by the industry because it wouldn't make money? So we heard 400 to 500 million, I think, or what is so? Can you put it in that kind of term?
Sure, 10%, 10% to 20%.
Yeah, just to follow up, I think 2 points is, first of all, I do think that the issue with the animal kingdom is a huge one. I was one of the very early supporters of the One Health approach, realizing that the spillover phenomenon is there and it goes back and forth. Our group now, in fact, is becoming quite involved with the great ape Ebola vaccine project because we are losing great apes at, as you know, a tremendous rate due to Ebola, and something's happening there, and that's really threatens their existence. But let me just back up and say that one of the challenges we have, and this is one of the arguments I make in the book, is that we need a critical agenda that basically lays out why we're doing this. And, I had a number of meetings and I testified a number of times on Zika virus issues in the Congress. And I actually was told by one of the senior congressional leaders who said, if you could just show me how this virus is being moved on drones by ISIS, I can get you all the money you want. And, we often in public health do take that great shot at the Defense Department because it's so easy to do. If we could just convert one aircraft carrier or those kinds of things, which of course is nonsensical. But what we haven't done is made the argument why what we do is as strategically and tactically as important as having all those missiles ready to fire if you need to fire them. Because what we're talking about is going to happen. It's not an if, it's going to happen. And when it does happen, and I think your data shows, and it is true, the cost is dramatic. And it's not just what the outbreak does. I mean, one of those very sad facts of West Africa Ebola is many more people died from malaria, vaccine-preventable diseases, and diarrheal diseases in those 3 West African countries during the time of Ebola because of a lack of any kind of infrastructure for health care, and accentuated the problem there. So it's not just that they cause a problem, but it's even the add-on, the collateral damage issues. So we have to do a much better job of making the case why a publicly funded pull-through. Nobody asks philanthropic organizations to buy missiles or planes. Nobody asks a company who makes those to do them on good intentions. And I think that's where we need to, and that financing would then come where you're talking about, is how we make that case.
So the quick follow-up to that, since nobody else stand up, is it time for us to have a national vaccine production non-privatized capacity like some countries have done, South Africa, for instance, once upon a time. Is it time to think about that, to have this right?
Well, you raise a good point, and let me just say that the military's had this experience, and they have failed miserably twice to develop their own vaccine manufacturing capacity, because there is really a science and an art to making vaccines. That is very, very definitely an expertise that we need to have. I think that is where private sector can play a role. But imagine today, this is what we do with vaccines. Imagine the following. I'm the Secretary of Defense, Secretary of Defense, and I say, I want to buy a brand new aircraft carrier, so I want you two companies to make it. And in the end, I'll decide if I'm going to buy it or not, and I'll tell you how much I'm going to pay for it. Do you think any company would get involved with that? That's what we do with our vaccine manufacturing companies. We need a whole new business model to do that, where, and these companies in many cases, and I'm not an apologist for these companies, because on the other hand, there are those other drugs that they do very well on that are, like basically, boiling water. It's very easy to do. Vaccines are very tough. They do deserve to get a return on investment, but it could be an acceptable one that we all agree is in society's best interest, and they would do that. But they don't want to get in this stop-start thing where we'll invest $400 million, then tell us the program's ended. And that's what we have to get across, that we're not helping them or ourselves by not putting forward this kind of countermeasure priority. Then we can start working on pathogens.
I think we're 100% in agreement that we need a paradigm shift. We need to be thinking forward instead of looking backward and say, it was never economically viable to make vaccines. There's all this backward looking that is getting us nowhere. And it's the forward looking on both of these different approaches that I think we can completely agree, because things are coming, right? And we need to be ready.
So just before you ask, there's a lot of young people here. There are a lot of your professors and graybacks are here, but please, don't hesitate to ask questions.
Thank you both for your perspectives. Tiffany Wolf from the College of Veterinary Medicine. I'm just wondering if, I know a lot of the focus with PREDICT is preventing the zoonotic diseases, but I'm wondering how much, since you are looking at the interface, how much focus is also on preventing disease within livestock. We know, of course, zoonotic diseases, there's the fear factor, which drives a lot of the incentive behind this program, but food safety and security is equally as important, especially since we know that is a major concern for our population burden, and it contributes to our own health as well. So just wondering about that.
Yeah, so in the first 5 years, as I mentioned, that wasn't our focus. Our focus was sort of the proof of concept as to whether or not you could even practically look all the way at the source, at the wildlife. But in this current phase, we're very much working with the Food and Agriculture Organization, hand in hand, actually in the field, as well as at the highest planning levels, to think about the food security and biosafety, both, and actually funded by Department of Defense and through the Global Health Security Agenda, that is investing quite a lot, as well as USAID on the livestock side. So both in the laboratories to keep things safe when they do come in, but also to look at the just terrorism straight into food supply. So there is quite a bit more work. I think our team specifically is most interested in the cycling of viruses and how they might change and become more pathogenic to one species or another. That is more on the research side than on the preparedness side, but it helps us to identify that host plasticity piece. And while we're doing that, we're gathering lots of information about food supply. And I can tell you that very, very, very poor biosecurity in almost everywhere we work. I showed you some pictures. That's in a good place, actually. So it's certainly a big concern, and that's where I think that the fire can catch.
And just to follow up on that, you raise an incredibly important point, and I think we're faced right now with a major issue on our hands, and that is, with 7.6 billion people on the face of the earth, 1 out of every 8 people has ever lived is here right now. And we have a need for protein. And we know that poultry have become the fastest and most efficient conversion of energy to protein that we can feed to society. Well, what we're having happen right now with avian influenza is absolutely unprecedented. And talking to the animal husbandry people, the bird side, you can go back 100, 150 years where at least we didn't know about infectious agents. We knew about large die-offs of birds, and you could track that. Something is very different. You know, I've been involved with flu all my life, last 20, really intensely involved, and I know a hell of a lot less about flu today than I did 10 years ago. What's happening is unprecedented, and we don't know why. And we are threatening the very existence of global poultry production right now around the world. The H5N8, H5N6, the United States again. If another high-path virus blew back in North America, I'm convinced we would not stop it again. We might slow it down better than we did 2 years ago, but not stop it. And so I think you're absolutely right. We have, as a matter of human security, in this case food security, have a very, very legitimate need to know and to do something about the issue of avian influenza and what it's doing because of the issue around food security. It's a really big, important issue.
And Tiffany, all of those outbreaks I mentioned that are keeping me up right now, all but one are avian influenza outbreaks involving the food supply.
My name is Elizabeth Ellens. I'm a graduate of Concordia College and North Dakota State University. This question is for anyone who can answer it. In terms of spillover risk, have political instability and war been looked at as a potential factor affecting risk? And if militaries or independent scientists working within war zones have been studying this, is the data available for analysis, or is that proprietary?
I'm not sure I caught all the question.
Well, the political instability part, I can speak to
Yeah.
that. You might need to give us a refresher on some of the finer points of the question. But the political instability, I can tell you a huge amount of the reason that there is funding coming not just from CDC, which is funding quite a bit of this work, but coming from U.S. Agency for International Development and the Department of Defense through the Defense Threats Reduction Agency. Those are the three big agencies in the global health security agenda, two of which are about making friends and diplomacy, okay? So we're about building capacity, but why do we build capacity in countries? We build capacity to keep ourselves safe, not just from the pathogens, but from conflict, okay? So it is certainly, I never thought I would be at all involved as a diplomat, but that is sort of what my job has become. It's a health diplomacy piece, very interesting, but I'm not sure that, well, I certainly don't know the data sources from which you could use to analyze, but much of it is the Department of Defense a little bit different. There's a lot about protecting the warfighter, which might be the entree for the vaccine development that might finally work. But much of it is the health diplomacy, how we make friends, and making friends through health rather than through guns seems like a good idea to me.
I think also, just to follow up on that, one of the things today that is clear and compelling about the challenges we have is we no longer live in a world that is overseen by good governance in any way, shape, or form. What I mean by that is, back in the 60s, when it was decided to eradicate smallpox, and the potential was there with the vaccine, the conditions of the infection and so forth, two countries, the USSR and the USA, decided to do it. And when they decided to do it, every country was a domino behind one of those two countries. And when one pushed, all the dominoes went down. Everybody lined up. Even as recently as 25 years ago, I know this well because it was the 50th anniversary of School of Public Health, we had Bill Foege coming to speak here, had just left as director of CDC, he was at the Carter Center. President Carter actually was able to bargain and barter a peace truce for 3 days in the Sudan to vaccinate every child in the country for measles because of a deadly measles outbreak, and there wasn't one shot fired in 3 days. Today, we couldn't do any of those. We have over 40 countries in failed state status. We don't have a world power that can get everybody to line up and say we're going to do this. We see it with polio eradication in Afghanistan and Pakistan. And so it presents a whole new challenge to us to actually try to do this work at the same time we're dealing with all the political unrest and lack of in failed state status governments.
Okay, thank you.
Thank you.
Hi, Cheryl.
Dr. Mazet, I have a question for you.
Who are you?
What?
Who are you?
I'm Cheryl Robertson, School of Nursing, Chair of Population Health and Systems in the School of Nursing. And I was on the Respond project and was based in DRC. So I have a question about capacity development. And folks in this room that know me know probably what I'm going to ask, and that is that, as you know, 95% of the public health workforce in Africa are nurses. Nurses are not on the Respond or One Health workforce project. Most of my time in DRC and elsewhere, I'm still in the project, has been looking at developing capacity for nurses, because these are the folks that out in rural areas are going to be the first ones to see when something is going terribly wrong. And so in terms of your guys' capacity development work, I wonder if you can say anything about workforce development, capacity development for those folks who are at the very front line of recognizing when something doesn't look right in the community or in the clinic.
Yeah, I'm with you. I would like to put you together, maybe you already are, with Heather Young from our Betty Irene Moore School of Nursing. She and I have been talking a great deal about programs for One Health workers, we call them. So, and we do think that probably the right training space for that is in the nursing schools. Although I will say those aren't even nurses. Those community health workers are less trained than nurses as well.
Yeah, but they're supervised by nurses.
Right.
Yeah,
Often, yeah. Many, depending on the country, are also supervised just by the NGO, the Red Cross, or whoever paid them, which gets very confusing. So there's very limited amount of even guidelines, less than regulations, on what level of training people have that are working in communities and in clinics. And so
no guidance.
yeah, it's a dire situation. And so we don't have the frontline recognition that we need back to getting to the preparedness, to say where a vaccine should go. I mean, we could use the yellow fever 2009 example. Respond was quite involved, as was PREDICT in northern Uganda. Yellow fever hadn't been seen for decades in Uganda. Their whole viral institute was built just to diagnose yellow fever, and yet, because they weren't expecting it, didn't think it was there. This is back to my argument, hate to pull it back. They didn't diagnose it for months until a sample was exported to CDC months later. So, decent vaccine. It was delivered after the outbreak was over. Everybody got vaccinated. So this is my problem, is that if you can't detect and you don't know what you're looking for, you have this delay that lets the outbreaks get out of control. I think nursing at the front lines could really, really help that if they were trained to be that sentinel.
Absolutely.
But I've been going to other funders because I haven't gotten any traction. I tried Gates too; they didn't go for it. So we'll need to get together and figure out a way. And maybe it comes back to what Professor Osterholm said, and we need to think differently about the way that we package and message all of this. And it's all, for me, the forward-looking piece. For all three of what we're talking about, they're all really needed, and the commonality is how to look forward, get ahead of these things, be ready.
And I think just to follow up on that, I mean, you know very well that the first way to take out a group of healthcare workers permanently is Ebola. And that's why we need vaccines up for the upfront emergency responders, the healthcare providers, et cetera. Look what we did to the healthcare systems, which were already at bottom barrel in West Africa by losing those 470 some healthcare workers who died because of Ebola and caring for patients. So I think this is where countermeasures also can be really critical in terms of supporting those frontline workers, which are really very, very important.
Right. One of the more sobering events for me was when I was in Liberia. My role in an Ebola treatment unit was to replace 2 nurses who had died the week before from Ebola.
It's horrible.
Yeah.
All right.
Thanks.
Well, thanks for the questions. I'm afraid we're out of time. It's clear that our speakers have presented the two sides of the elephant on a very highly complex and interacting challenge. We appreciate all of you being here to help us think about it. We have one more talk in this series. It's on Thursday, April 13th. Dr. Julie Gerberding, MD, MPH, former director of the CDC and now at Merck. And her title will be Combating Microbial Terrorists, How to End Our Preparedness Stalemate. And clearly the next episode in the conversation we've been having here. So thank you all for coming, and let us please thank Dr. Mazet and Dr. Osterholm.